All right, next one here. We have one of the problems here. This is on your formula chart. This is dealing with segment lengths. If you look at your formula chart, here, let me show you. That is going to be this formula right here. You got a secant line and a tangent line. We're finding one of those pieces right there. So that's going to be here x squared, and then that's going to equal 4 times the sum of those right there, 4 plus 5 right there. Okay, so basically 4 times 9 right there, and that will be 36. And then to undo the square, we square root, and that'll get us x is 6 on that right there. So using one of those formulas. Number 10 is not going to use any of those formulas here. We need to remember that two tangent lines from a common point are going to be congruent. So what does that mean here? If this thing right here is 4, that means this other side right here, this other piece of the tangent line must be 4 centimeters as well. Okay. If this piece right here of the tangent line is 3, that means this other piece here must also be 3 as well. Right there. They gave us the full thing here, and some of y'all might be saying, well, why am I finding that? Well, eventually that's going to help us find this piece right over here, but we got to work our way around. All right, now if the whole thing is 5, but then this one piece here was 3, if we go 5 minus 3, that's going to get us 2 centimeters, and that'll be this piece right here. And then if that's 2 centimeters, then this is also 2 centimeters based off of the property, two tangent lines from a common point. And then to go get this last piece right here, we technically do 4 and it's minus 2, and it happens to come out to the same thing, and that was a coincidence, but that should be 2 centimeters there, and then therefore this piece here should be 2 centimeters. Usually when you are finding the perimeter of these things, all you need to do is just go add up all of your sides. So you could say, okay, that side right there is 7. This side here, they told us to be 5. This side here, they told us to be 4. And then this side right here, we add the 6, the 4 and the 2, and that gets us to 6 right there. And I think that comes out to 22. Let me double check. 12, 16, and then plus another 6, 22. And then with the units, that'd be in centimeters. Okay. Number 11, I think you see a few of these problems here where you need to redraw your own radius here. All right, if you have a perpendicular line right there, technically these are being the same right there. Technically that chord is being bisected, and then we can redraw a 10 right there. Okay, another radius. So the big idea is you might need to redraw a radius, and you can redraw that radius wherever you want. No matter where you draw it, it's always going to be 10. And then it's a little crammed there, so I'm going to redraw it here, but we have a right triangle, and apparently, let's see here, we have 10 for this side, and then we need to go and find x. Oh, okay, I'm trying to think here. With this one here, we only have one side of the right triangle, so that's not going to help us go find x, which would match with this right here. So we're out of luck there. To go find this bottom piece right here, notice that the radius should still be 10 right there. All right, so if we go and do 10 minus 4 right there, that's going to get us that bottom piece right there, which would be 6. And then from there, we can go and use our Pythagorean theorem. We can go and say x squared plus 6 squared equals 10 squared. Okay, and then this will come out nice and clean. This is one of the Pythagorean triples. If you don't recognize that, it's not a big deal. Just regular Pythagorean theorem should get you 8. So if that is 8 right here, then that means that piece is 8 right there because it's going to be bisected. Okay, and that property is only true if you have a perpendicular line and it is a diameter or a radius right there. So that's that. Number 12 here coming up. This is another one that's going to be from the formula chart. So the formula that we'll use here for this one will be this formula right here. So you got two secant lines, and we're going to try and find a piece of that secant line. So the way this will work here, this will be 8 times the sum of those. So I guess a plus x, or x plus a, however you want to write it. And then the other side will be 9 times the sum. So 9 times 9 plus 12 or you could call that, 21. Over here, I'm going to go ahead and distribute this guy here, 64 plus 8x. Over here, you can technically add those first, so I'm going to do 9, and then that should be 21. 9 times 21, let me grab my calculator. Apparently 189. Okay, and then I'm going to go ahead and subtract 64 from both sides. That'll be 8x is 125. And then I guess this one doesn't come out clean after you divide by 8. Comes out to 15.625. And that's for x right there. As long as I didn't make any arithmetic errors. Double check. Yeah, but I think we're good. 9 plus 12. Yeah, I guess that one just didn't come out very clean there. Okay, making my key here as I go. All right, next here, this one you got two tangent lines. If you look on your formula chart, there's not really a formula for two tangent lines. We got the two secant lines and then one tangent line and a secant line. And that's because we want you guys to remember this property here. Two tangent lines coming from the same point, just like the perimeter problem we did, are going to be congruent. So all you got to do here on this is 40 equals 3x plus 4. And then you can subtract the 4, that's 36. And then you can divide, that's x is 12. So that'll be that. 14, we're going to use the idea, the property that tangent lines to circles make a right angle with the radius. So that is a right triangle. And then also another property here, not really a property, I guess just common sense here. If the radius here is 8, that means the radius over here is also 8. And then we'll go and do Pythagorean theorem by going x squared plus 8 squared, and then 8 plus 9, that'll be 17 squared. I believe this one is also a triple. Sometimes people don't know this triple though, so I'm going to go ahead and work it out. 289, oops, and then subtract 64. Yep, there we go. X squared is 225, and then the square root of 225 is 15. Just be on the lookout. If you get a number that's not a perfect square, you will need to use the simplest radical form and break down the radical. I do believe that is on the test. I'm sure it comes up here on the review eventually. So.